Okay, everyone. Today my calculators come in. There are two calculators for $9. Good deal. This calculator here is the TI 30. It's really old. I don't know if it says in the back here what date it was made. It says assembled in the USA, but we don't get no date. I'm pretty sure it's old. LEDs they don't use in calculators because why? Because every LED usually has to have 20 milliamps of power to power each LED, and you have to have 7 for each digit. The more digits you have, the more that current's going to add up to. It might be a little bit smaller than that since this LED display is tiny on the screen. It might not be 20 milliamps. Might be a little less. I could test with we'll do a test with it in a little bit about with my power supply. I changed 9 volts, but I have my other calculator hooked up to the two. I got 2 calculators. This calculator here, there's a glitch in it. You know, 0 to the 0 power is undefined. Well, watch. If I type 0, where is the key? Raised to the power 0, it equals 1, it says. That's incorrect. You can't have 0 to the 0 power. As if I do on this calculator over here, turn it on, hope you can see that. 0 raised to the 0 power, it gives me an error, see? Error domain, probably telling me the numbers are not in the right domain or range. So this calculator here has a glitch in it. It can't calculate 0 to the 0 power correctly. It's not 1, it's undefined. It thinks it's 1 because usually every number you usually enter into there that for the base raised to the power 0 should be 1. I wonder if it does the same thing. It probably, let's try entering 2 to the 0 to the 2 power. Second, 0 squared. Does that correctly because 0 squared is like that, but when it comes to 2 to the 0 to the negative to the 0 power, it's incorrect. I have this here powered by the power supply over here. That's why it looks funny right here, because I didn't have no AAA batteries. I wanted to see if it worked on it, so what I did is I found the positive negative terminal for the batteries go in the back, and put 6 volts in it. Since 1.5 that's what a AAA battery has, 1.5, and times it by 4, I used the 6 volts. So I had to input 6 volts, and I had 5 into it earlier, and you can't really see nothing on it. But when it went to 6, you could see the screen better. And the guy said it was a blue screen, but it doesn't. It's not a big deal. It works perfectly fine. I don't know. Maybe the calculator got old, and the screen that was the side effect of the screen that would get blue for some reason, or maybe the screen got a little bit, wore out. Anyway, it does graphing on this thing. I could hit that key about there. You can see the y equals screen. That's in the equation. And 5x plus 3, and I want to see what equals 5. It's the intersection point. Now if you use this here, the thing about this calculator here, it's kind of like TI-82 is the one before the TI-83. So it's not that bad of a graphing calculator. It's sort of similar to the TI-83, except it does have logistic regression on it. It doesn't have zoom fit. It doesn't have the 0 in this calculation memory in the menu. So if you want to measure something for y equals 0, you're gonna have to put in there in the equations list 0. Now let's try finding the intersection, which is number 5. Hit number 5. First curve, second curve, 0. Is that correct? I put 0 into the equation. You got using plus 3. I put plus 3 on it, didn't I? 5x plus 3. And we know equals 5. Actually, it's a decimal number. It's a... We'll try it again. Second, here. Okay? Maybe I didn't have it in there correctly. First curve right there. Second curve. It's actually 0.4 is your x, and it does pretty good. And let's try putting 0.4 into the equation. Get out this. How do I get out of here? This key. So it's 5 times 4 plus 3. Not 5 times 4. 5 times 0.4, I mean. Plus 3. Gives us 5, so that worked. The thing is, and also thing I just noticed when I was playing around with it, the regression is different than the TI-83. Because if you go here, type that in, you're supposed to put your list. You can put lists in it, or you just do what list 1, list 2. But when I hit, it says list there, but when I hit Shift, second stat, it brings that menu up. Why would it bring that up? It's supposed to bring me the list of variables for the list for each list stored in there. But that's okay, because you can just, but then you can't, I also noticed I can't put the function in where I want to store the stuff. So they must have put that, and that must have been a new features in the TI-83, is that they have variables you can specify on the linear regression command to store where to store the equation, and also know which list you want to use for X and Y. I don't think I had nothing in the list, so that's why it said undefined. There's nothing in the list. Anyway, yeah, this will do a nice calculator for my math class, algebra class, taken online through Arizona State University of a Global Freshman Academy course. It's free. It's a total free class. You don't have to pay anything to use it. You do need a webcam, and you should have a calculator, because they don't let you using computerized calculators, I don't think, and do the final exam. Anyway, now you want to see how much correct this thing's drawing. Okay, I'll go hook it up. Okay, sorry about this. I can't show the camera. It's on the screen right now because I'm using one hand. Maybe I can. Let's see if I can do it. I got the 0 being displayed, and we're drawing about 10 milliamps off there. Let's try putting 8 in. Still 10 milliamps. 2 8s. Still 10 milliamps. 3 8s. Now we got 20 milliamps. Still pretty good. I guess these LEDs, well, still 10 milliamps ain't that great. You still would not have that much power as you would if an LCD calculator. And that's why I don't use these LED displays. Only the ones that do for like, what do they call it? Ones you use for when people go shop, when people buy stuff from you, you make a receipt with it. And it plugs into the wall. Now it's doing this cycle thing there, not drawing hardly anything on it. I put a 3 in. I'm gonna put 1, 2, 3, 4. 4 eighths. And we're gonna get in with 4 eighths, about 30 milliamps. 5 eighths, still 30 milliamps. I have eighths of this being displayed on the screen. 6 eighths, 40 milliamps. 7 eighths, 40 milliamps. And finally, 8 eighths is the last number. It can go up higher, how high it can go. And we're getting about 550 milliamps. Half 100 milliamps for that many digits. But that's just with all the digits with the 8 on it. Now, what we're gonna do is we're gonna go into the calculator. I'll show you a little trick. I know that these batteries have like 600 milliamp hours. We're gonna figure out how many hours will this thing last if it constantly drew those milliamps we got. Different ranges. I'm going to show you that. There's easy math formula that goes with electronics. Amp hours means amps per hour. So we'll be finding out how many amps we'll get, how many hours we'll get. Okay, what we know is we got 0.6, and we just divide it by 0.0, too far, 0.6 divided by, no, hang on, 0.6 divided by 0.00, too far again. I'll just do it on the different, I'll see about Wikipedia, see if we get, this calculator looks good for the camera. I might use this one for my videos. Because you can see what's on that screen there compared to this here. You can't hardly see it because it's not lit up. 0.6 over, come on, 0.6. It's hard getting used to this. It doesn't like that you have to probably press on it. 0.04. Only 15 hours you would have. That's not very much. That's even less than a day. 15 hours, that's what 40 milliamps will have on there. What about 10 milliamps, like it does with one digit? Let's see how well it does with that. 0.6, since we're doing 600 milliamps, over 0.01. 60 hours it will last. That's only, how many days would that be? We can figure that out by dividing this by 24. This is hours. 24. 2.5 days. About 2 days and a half. It'll last on if this thing was on all the time. But the thing is, it automatically puts it in that screen where it goes like where the dots are going across it, so it keeps itself in memory, and then also you can. And then when you want to turn, it turns itself off at the 7, and it comes with manual here. I haven't showed you the manual. The manual's pretty good. I like the manual. This didn't come with manual. The guy didn't have it. This is probably why the screen's blue. Because you see right there, there's a little bit of black right there. But it's not that bad. It might have just got pressure against it or something. I don't know. This here is pretty good. It just tells you we have the features, we have the key and definition index. This calculator might be the one I use for my videos, because I don't have to use that with hard math to do stuff. It does pi, which is recommended if you do electronics, because something you have to do with pi, the value of pi, which it has, which is nice. It has square root and has powers, which is good. It has 1 over x, so if you if you're trying to do parallel resistance or the reactance of an inductor, you'll be able to have it, because you have to do 1 over it. So this is basically about the features on it. Features. Let's see what the features are. Complete solid-state circuitry with high-quality components. Sealed keyboard to minimize dust and moisture accumulation. Electronic on-off provides for special power and saving functions. Only a traveling decimal is left in the display after typically 25 to 50 seconds of non-use. The previous displayed value is retrieved without interfering with repeating operations. The TI-30 turns itself off completely after 7 to 14 minutes of non-use. Will never waste the battery by forgetting to turn off your calculator or have it on accidentally. Algebraic method of entry allows you to enter mathematical sequences in the same order that they are algebraically stated. It goes to these here are the pages it has about the optional accessories, rechargeable kit, ooh, there's a rechargeable kit. I don't know if they can get that. They had rechargeable batteries back then? I don't know. Okay, I'm reading about that. There's a button to do the digit keys, a decimal point, a sign changer, the pi key, the addition key, the subtract key, the multiply key, the divide key, the equal sign. And it goes on with all these keys here, shows what they are. Just remember, with this calculator here, you have a 0 raised to the power 0. It's going to come out to 1 on there, which is incorrect. It's undefined. Degree, radical. It's a pretty amazing thing. Well, I think that's about it. And it didn't take very long. It only took about like maybe 3 days or so. They just come to in order to kind of pick up for where they come deliver it. It was off of eBay. The calculator right now is saving the power. So if I put on there, we'll have on. What about 50? We didn't do at 50. Let's try 50 milliamps at 600. Only 12 hours and strong 50 milliamps. I think that's what I got calculated. Yeah, that's what I calculated for all digits. All 8 digits with 8 on it used. And that's why they don't make calculators with LEDs anymore. The good thing about calculators with LEDs, you can use it on a camera like this and people be able to better see what's on the calculator screen than it is on with one of these regular LCD screens. Even though this is a pretty good calculator, it's graphing on it. I'm glad I got the deal with got two of them from the same person. Well, that's about it. So I hope you enjoyed this video. And so I hope you subscribe and thanks for watching if you like it.